Hello everyone, welcome to MEMONEET. So I'm Aprajita, your chemistry SME. I welcome you all to another amazing lecture at MEMONEET. So today students, we are here to study another interesting chapter, that is coordination compound. I hope your last BPT 10 went well and all of you scored good marks and you have watched all the lectures that we have uploaded till now. So in case you are facing any issues or any problems, you are not able to understand anything, so you can contact us, you can join the Telegram channel, you can contact us through that, we are available there. Or else if you are having any issues, you can comment down in the YouTube comment section, we will see to it and we will cater to your doubts. Okay, so please let us know what problems, what issues you are facing while preparing for the NEET examination, right? Okay, so as we are taking one or two chapters each for each BPT. So for BPT 11, the next Brahmastra part test that you are going to have, we are having another important chapter, that is coordination compound. So coordination compound itself, it's an important part of inorganic chemistry, and you know coordination compounds also, they make a big part of inorganic and bioinorganic chemistry. So that is why their study becomes important for us. And in this chapter we will get to know about what is coordination compounds, what are the different theories behind it. Okay, we'll be learning about the valence bond theory, the crystal field theory, and we'll be learning it in detail. Okay, so for today we are just talking about the introduction, because see, this is a very new chapter for us, so we will be learning certain terms. All right, so for each chapter we are learning certain new terms that are there. So for coordination compounds also, there are certain terms like ligand, coordination sphere, all of that, that we will be getting to know today. Okay, I'll be talking about the Werner's theory. Okay, that's a very short theory. Werner's theory we will be talking about, and then we will be talking about the nomenclature. कि how to name the coordination compounds, just like we name organic compounds, na carbon compounds, just like we name them, we will be naming the coordination compounds as well. Okay, so these are the topics that I am going to take in today's lecture, so stay till the end, because at the end we will be learning about the nomenclature, which is very important. Okay, so we will be starting with the introduction part, that what are coordination compounds actually. So you have not we have not discussed transition elements till now, but you know these coordination compounds are mainly, means other compounds can also form, other elements can also form coordination compounds, but these are mainly formed by transition metals. Okay, so basically coordination compounds are the addition molecular compounds which retain their identity in solid state as well as in dissolved state. Okay, and in these compounds the central metal atom or ion is linked by ions or molecules with coordinate bond. This is very important कि there is coordinate bonding in it. So you know that what is coordinate bonding, we have already studied about chemical bonding chapter. So in coordinate bond, the electrons are shared by one atom only. Okay, so in this case it can be the metal atom, it can be the ligand, or anything which will be sharing the electrons. So basically it's a coordinate bond. All right, and these are addition molecular compounds. Now what are addition compounds, let's try to understand. When two or more than two simple salts are allowed to chemically combine in a fixed ratio, then addition compound is formed. Okay, so we are actually just chemically combining two or more than two simple salts, which will give you addition compounds. So two type of compounds can be formed. First one is double salt. Okay, now what is double salt? So addition compounds in which simple salts do not lose their identity. Okay, salts will combine, okay, they will combine chemically, but they will not lose their identity, and its aqueous solution give test of all constituent ion, कि every constituent ion का हमें test वहाँ पर मिलेगा in aqueous solution, means they lose their identity in aqueous solution. For example, here we are making a double salt, okay, so basically see KCl, magnesium chloride, so this is a double salt that is formed, but in aqueous solution it will convert back to potassium magnesium chloride ions. Okay, so it means what is happening in this case? It is losing its identity in aqueous solution. But if I am talking about complex compounds में ही हमारे coordination compounds आ जाते हैं. So addition compounds in which simple salts lose their identity and its aqueous solution does not give test of all constituent ions. Okay, so salt will lose its identity and the aqueous solution does not give test of all constituent ions. So like here we are having potassium ferrocyanide. Okay, I'll tell you how to name it also, don't worry. Okay, so you can see here that in this bracket, whatever salt is there na, in aqueous solution also it is not getting ionized to give you ferrous ions or cyanide ions. That is the main difference between the double salt and complex compound. So that's what we are saying, ki in coordination compounds, that compound is going to retain its identity in solid state as well as in dissolved state also. It is not going to ionize. Okay, now we will be learning before learning the Werner's theory, we will be learning some important terms pertaining to coordination compounds. So the first term is coordination entity. Now what is this coordination entity? It constitutes the central metal atom or ion bonded to a fixed number of ions or molecules. Now what does that mean? So means here we are having this compound, let's write it, cobalt Cl3NH3 thrice. So this whole thing is a coordination entity. Okay, this is a coordination entity, means here it is talking about the cobalt ion which is surrounded by 3 ammonia molecules and 3 chloride ions. So this whole coordination entity, it is written in square brackets. Always we will not be using round brackets, we will be using these square brackets for showing or for writing the coordination entity. Okay, other example you can see here, there are various examples given here. So this coordination entity is telling us about the central metal atom or ion bonded with a fixed number of ions or molecules. Okay, now what is the central atom or ion? So in a coordination entity, the atom or the ion to which a fixed number of ions or groups are bound in a definite geometrical arrangement is called the central atom. Okay, so central atom means where all these fixed number of ions or groups they are bounded to, that atom or that ion will be known as the central atom. Like here in this case the central atom is the cobalt. Okay, so next we have NiCl2H2O4. So here with nickel, 2 chlorine and 4 water molecules are attached, 2 chloride ions and 4 water molecules. So here the the central atom will be nickel 2 positive ion. The charge whatever it is we will talk about it later, but try to understand ki these are the central atoms in this case or ions. Okay, so we will be calling them as Lewis acids also. So अभी हम पढ़ के आए हैं what are Lewis acids. These are electron acceptors. Okay, so in this case the metal atom will be the one which will be accepting the electron. Coordinate bond बनेगा, so ligand will be the one which will be sharing both of its electron, means ligand will be the one which will be sharing the electron pair. Okay, so that's why we are calling the central atom or the ion as Lewis acid. Okay, next, ligands. So ligands are the ions or molecules which are bound to the central atom in the coordination entity. So apart from this central atom, whatever groups are bounded or bound with the metal atom, we will be calling them as ligands. So they can be simple ions also like chloride ions, small molecules like water, ammonia, or they can be large molecules also like ethylene, diamine, okay, or pyridine or many other, like whatever it can be, or even macromolecules can also be there like proteins. तो ligands के बारे में we need to know some more things. Now what is that? There are different types of ligands. Okay, now the first is monodentate ligand. Now what is this mono to you know one, right? Okay, now what is monodentate means? Monodentate means the ligand that has one donor atom only. ओके सिर्फ एक ही डोनर एटम होगा उस पर्टिकुलर लिगेंड में, मींस दैट वन डोनर एटम विल डोनेट वन इलेक्ट्रॉन पेयर टू द सेंट्रल मेटल और आयन. तो अभी हमने क्या देखा कि दैट लिगेंड इज द वन विच इज डोनेटिंग इट्स और शेयरिंग इट्स इलेक्ट्रॉन पेयर बिकॉज मेटल एटम और आयन इज अ लुईस एसिड. ओके, so if there you are having just one donor atom, so it will just donate one electron pair. Okay, for example अब इसमें we have different types: neutral, cationic, anionic. Neutral ligands which are not having any charge, cationic ligands having positive charge, anionic ligands having negative charge. So these are the names also that are given to the ligands. Like if water we are taking it as ligand, we will be calling it as aqua. So here in water, which one is the donor atom? In water, you know that oxygen is the one which is having lone pair. So oxygen will be the one which will be the donor atom in this case. Only one donor atom, no donor atom apart from oxygen. Similarly in NH3, amine. In amine, you know nitrogen will be the one which will be the donor atom, right? Because it is having a lone pair. So there is a necessity of lone pair also. We want that electron pair also. Okay. So in then we have carbonyl, thiocarbonyl, nitrosyl, methylamine, urea. Like it can be any kind of molecule. Okay. Now in cationic we have O2 plus, NO plus. Okay, these are cationic ligands. Then anionic ligands may your negative ions, mainly fluoride, chloride, bromide, iodide. Okay, so you know they are electron rich. O2 negative, NO2 minus, nitro, azido, hydrido, sulfido, like S2 minus. So these are monodentate. Try to understand. Monodentate means which only have one donor atom, means they will donate only one electron pair to the central metal atom. Okay, so now if you have monodentate, you will be having bidentate also. Bidentate means when a ligand can bind through two donor atoms. Okay, it's said to be bi or didentate भी बोल सकते हैं हम इसको कई बार. Okay, bi or didentate means अब यहाँ पर दो donor atom होंगे. For example, ethylene diamine. Now what is ethylene diamine? Ethylene diamine is CH2 CH2 NH2 and NH2. अभी आपने ऑर्गेनिक नहीं पढ़ी है. इफ यू स्टडी ऑर्गेनिक यू विल फाइंड दिस मॉलिक्यूल देयर बहुत ज्यादा. ओके, सो इट इज इथिलीन डायमीन और इथेन 1,2 डायमीन, क्योंकि इथेन में एक एक हाइड्रोजन हटा के हमने अमीन ग्रुप लगा दिया है. नाउ व्हाट हैपेंस इज यहाँ पर हमारे पास दो डोनर एटम है. तो अब कौन से दो डोनर एटम है? टू नाइट्रोजन. सी वन नाइट्रोजन इट इज हैविंग अ लोन पेयर and another nitrogen it is having a lone pair. So both of these can donate their electrons to the metal ion, okay, or the central metal atom or ion. तो अब यहाँ पर there are two donor atoms. Okay, two donor atoms. So if there are two donor atoms, it's a bidentate ligand. Okay, all right. For example, we have oxalato also. oxalato को हम OX से denote करते हैं, but this is C double bond O, C double bond O, O minus, O minus. Now these two O minus are the two donor atoms, okay, which will donate their electrons. Clear? So this is bidentate. Now we have polydentate ligands. Polydentate means if there are more than two, means when several donor atoms are present in one ligand. I told you na ki ligands तो simple भी हो सकते हैं, but they are complex molecules also sometimes. तो when they are complex molecules, it can be possible कि वहाँ पर एक से ज़्यादा donor atoms हो. So then we will be calling it as a polydentate ligand. So there is a very important polydentate ligand which we study. I am telling you some examples. There are more examples to it. Okay. इथिलीन डायमीन टेट्रा एसीटेट. ओके, इथिलीन डायमीन टेट्रा एसीटेट EDTA हम इसको बोलते हैं, EDTA 4 माइनस. ओके, EDTA क्या होता है वैसे? इथिलीन डायमीन टेट्रा एसिटिक एसिड. एसिटिक एसिड में यहाँ पर हाइड्रोजन होती हैं चारों. ओके, तो अब इसकी हमने आयन बना दी, टेट्रा एसीटेट आयन बना दी, तो यहाँ से हाइड्रोजन चले गए, इसलिए 4 माइनस इस पे चार्ज है. ओके, नाउ इट इज हैविंग 6 डोनर एटम्स. हेक्साडेंटेट लिगेंड हो जाएगा ये. 6 डोनर एटम्स मींस 4 तो ऑक्सीजन है and 2 nitrogen also. Okay, 2 nitrogen and 4 oxygen, so it can bind to the central atom from 6 atoms. Okay, so that is why we will be calling it as a hexadentate ligand. तो ये polydentate में आ गया. Okay, so if there are several donor atoms we will be calling it as a polydentate ligand. तो अब अगर हम बात करें polydentate or bidentate ligand की, so in the same metal atom, to the same metal atom, they can combine through more than one atom, right? उससे पहले हम देख लेते हैं ambidentate ligand. Now what are ambidentate ligands? Let's see. So there are certain ligand students which have two different donor atoms, but at the time of coordination they can coordinate the central metal atom by either of the two donor atom. Like we have cyanide, okay, so MCN is there, so C triple bond N is there, so it can coordinate or it can combine with the metal atom through carbon also, okay, and through nitrogen also. So if it combines with the carbon, we call it cyanido. If it combines with nitrogen, we call it isocyanido. So it can combine with more than one atom, okay, so that is known as ambidentate ligand. So that is the thing. Like similarly we have NO2 also, so it can combine with nitrogen also, or it can combine with oxygen as well. So we have learned about di or polydentate ligand. So when they use two or more than two donor atoms simultaneously to bind a single metal atom, it is said to be a chelate ligand. And the number of ligating groups is called the denticity of the ligand. Like we were discussing, unidentate means denticity is 1, bidentate means denticity is 2, like that, okay. So such complexes, they form chelate complexes, and please note जो chelate complexes होते हैं, okay, they are more stable than similar complexes containing unidentate ligands, okay. Now the next term is coordination number. So coordination number of a metal ion can be defined as the number of ligand donor atoms to which the metal is directly bonded. Like if I am talking about PTCl6 2 minus, and here we have nickel NH3 4 2 plus. So the coordination number of platinum will be 6 and coordination number of nickel will be 4. Means how many ligands it is bonded to, that will be the coordination number, okay. Now but try to understand in case of let's say bidentate ligand. So this is oxalate, okay, so oxalate is attached here to iron. So if I ask you what is the coordination number of iron, so you will say 3, but 3 would be wrong. Why? Because this is a bidentate ligand and it will combine by two atoms, okay. So in that case 3 into 2, the coordination number will be 6. In the same case of ethylene diamine also, the coordination number will be 6 because they are bidentate ligands. Next is coordination sphere. So the central atom or the ion and the ligands are attached to it. Which are attached to it? They are written in the square bracket. So this square bracket is called the coordination sphere, okay. And whatever ionizable groups are there, they will be counter ions and they will be written outside the coordination sphere. Like in potassium ferrocyanide, here you can see, I told you now that it will not ionize. FeCN6 will not ionize, but it will ionize. Potassium will ionize, which is the counter ion, okay. And here you will be getting FeCN6 4 minus. So in that case, this potassium ion or this square bracket will be your coordination sphere. Next, coordination polyhedron means the spatial arrangement of linked ligand atoms which are directly attached to the central atom. So that will be telling you about the geometry, okay. Like we have octahedral, square planar, tetrahedral. Like CONH3 6 is octahedral, NiCO4 is tetrahedral, PTCl4 is square planar. So you can see different polyhedras here. Like this is how the shape would be: octahedral, tetrahedral, square planar, trigonal, bipyramidal, square pyramidal, okay. Next is oxidation number of atom. This is also important. So oxidation number of the central atom will be the charge it would carry if all the ligands are removed along with the electron pairs, okay. So then whatever charge is present on the atom, that will be the oxidation number of the atom. So oxidation number we always write in the Roman numerals in parenthesis, followed by the name of coordination quantity entity. For example, if I want to write the coordination number of copper in this case, so I'll write Cu and 1. So that I have to write in Roman numbers. Next is homoleptic and heteroleptic complexes, which is again important. Homoleptic means in which a metal is bound to only one kind of donor groups, okay. Like here all the 6 groups are ammonia, one kind of group is there, so it's a homoleptic compound. complexes in which a metal is bound to more than one kind of donor group is heteroleptic. Like here we have 4 ammonia and 2 chloride. So इस पर एक question भी आया था NEET में, right? The question was asked in NEET also on this homoleptic and heteroleptic. So don't skip these small things. Don't think, yeah, this is just introduction, this is small. No, questions are asked from here also, because whatever lectures we are doing, they are all NCERT based, and in NEET NCERT is very important. Okay, so questions are directly or indirectly asked from there only, so never skip such important yet small things. Okay, next, if I talk about Werner's theory, so he gave us a concept of two type of linkages, primary and secondary, which he called as valences also. So primary valences are, he said ki they are normally ionizable and they are satisfied by negative ions. So the ones that are ionizable, that would be the primary valences or linkages, and the secondary valences are non-ionizable. They are satisfied by neutral molecules or negative ions. And you know, the secondary valence will be equal to the coordination number. कि कितना coordination number, like 6 if it is there, so 6 number of secondary valences would be there, and it will be fixed for a metal. Okay, so the ions or groups bound by the secondary linkages to the metal have characteristic spatial arrangements corresponding to different coordination numbers. Alright, so they will be having different arrangement according to the different coordination number. And just now we have discussed these spatial arrangements are called coordination polyhedra. Okay, so you know कि जो species हैं, with the ones that are there inside the square bracket, they are coordination entities, and the ones that are outside it are called the counter ions. Okay, so Werner said that there are certain shapes like octahedral, tetrahedral, square planar, which are most common in coordination compounds of transition metals, like CONH36, COClNH35. These compounds, they are octahedral, NiCO4, PTCl4 are tetrahedral and square planar respectively. So he just talked about the primary and secondary valences. So that is the important feature of this theory. Okay. So you just need to understand that primary valences are are ionizable and secondary valences are non-ionizable. Now, next is nomenclature. So firstly, how to write the formulas of mononuclear coordination entities. Okay, so formula is just a shorthand tool to provide basic information about the compound. Okay, mononuclear coordination entities means where we have just one nucleus. One nucleus means there is a single central metal atom. Okay, so central atom is listed first. So hamesha we will be writing the central atom first. Then the ligands, they are written in alphabetical order. Okay, the placement of ligand does not depend on its charge, but it is written alphabetically. Alright students. Now, polydentate ligands are also listed alphabetically. Okay, in case of abbreviated, like for oxalato we write OX, for ethylene diamine we write EN. These are abbreviated ligands. The first letter of the abbreviation is used to determine the position of ligand in the alphabetical order. Okay, so we'll be using the first letter in that case. And the formula of entire coordination entity, whether it is charged or not, it is there in the square brackets that I've already told you ki every time we will be using the square brackets only. When ligands are polyatomic, their formulas are enclosed in parentheses. Like we will be, like here you have ammonia and you have to write 6 ammonia. So you will be writing ammonia in parentheses and then put 6 there. Okay, right? And ligands are also enclosed in parentheses. Like if you have ethylene diamine, so ethylene diamine 2, like this you will be writing. Now, when the formula of a charge coordination entity is to be written without that of counter ion, okay, like if we are not using the counter ion, so then you have to write the charge outside the square bracket in the right hand superscript, like COCN6, and here you have to write 3 minus. Okay, if counter ion is not written. And the charge of the cation is balanced by the charge of the anion. Like here if we are having 3 minus, so if I want to write counter ion, so I'll be writing K3, okay, or Fa3, like that. Alright, so this is how we will be writing the formulas. It's easy. Now how to write the name. Again, the naming is done according to the rules by the IUPAC. Okay. All right. So now what are the rules? Let's say cation is named first in both positively and negatively charged coordination entity. Whether it is positively charged, whether it is negatively charged, like here we were taking now. So whether it is positively charged or whether it is uh, your negatively charged. Sorry, CN6. Okay. So in that case, cation will be named first. Okay. Then the ligands are named in alphabetical order before the name of the central metal or atom. कि central metal atom का जो नाम है वो सबसे last में लिखेंगे. Okay. Now name of the anionic ligands ends in O. जो anionic, just now I told you know what are anionic ligands. Let's go back there and let's see. Anionic ligands were here. See, so their name ends in O. Fluoride ion is there, so fluorido or fluoro. Chloride is there, so chlorido or chloro. So we will be writing O at the end. Okay, that is the thing. Now for neutral and cationic ligands, same except like same name we will be writing, but there are certain exceptions. Like for H2O we use aqua, for NH3 we use amine. Okay, amine, we call it as amine, double M na. Carbonyl for CO, nitrosyl for NO. And for coordination entities we have to write the name in brackets. Okay, now prefixes will be used if there are more than one ligand like mono, di, tri, etc. to indicate the name number of individual ligands. When the ligand itself is having a numerical prefix, okay, like if you are having triphenyl phosphine, this is triphenyl phosphine. Okay, अब दो triphenyl phosphine है तो how you will write? So in that case you will use bis, tris, tetrakis. So you will be writing bis, then you will be writing triphenyl phosphine because tri already hai, so I cannot write bi here. Okay, so I have to write bis. Okay, so like here it is written bis triphenyl phosphine nickel 2. Now oxidation state of the metal has to be written in cation, anion or neutral coordination entities. It is indicated by Roman number in the parenthesis at the end. Okay, now if the complex ion, जो complex ion है, where if it is a cation, the metal is named same. Like if it is a cation like this, if it is a cation positive charge, so metal is named the same as the element. Like cobalt will be written as cobalt only, platinum will be written as platinum only. But if it is an anion like here CO, SCN4, 2 minus. Now it is an anion, so while writing the name of the metal, you will be writing the suffix ATE. ATE, like it will be cobaltate. Okay. Or for some metals, we will be using the Latin names. Like for iron, we will be using ferrite. Okay, like if there is platinum, we are using platinate. Or Latin names use karte hain. Like for gold, we use aurate. For silver, we use argentate. So these are the Latin names. ATE kab aayega? When the coordination entity or the complex ion is an anion. Okay. And the neutral complex molecule is named similar to that of the complex cation. Okay, neutral molecule के लिए same रहेगा. Now let's take one or two example. Rest you can practice. All right. Like here, this compound is given CrNH3 thrice H2O thrice square bracket then Cl3. Name is written. Okay. Now let's see the complex ion, whatever it is inside the bracket, which is a cation. Of course, it's a cation because 3 chloride है, तो इसका मतलब इसके ऊपर यहाँ पर 3 plus charge है. Okay. The charge is 3 plus and you have 3 chloride. Okay, so charge कैसे पता लगा मुझे? Because 3 chloride है, each chloride has -1 charge, so complex ion के ऊपर +3 charge है. Okay, so यहाँ से we can find the coordination number of the the oxidation number of the metal also. So ये दोनों ही neutral ligands हैं. Okay, so अगर मैं oxidation number निकालूँ भी, so 3 into 0 because mine and water both are न्यूट्रल. सो टोटल चार्ज कितना है +3. तो यहाँ से x की वैल्यू भी कितनी आ जाएगी +3. मीन्स द ऑक्सीडेशन नंबर ऑफ क्रोमियम विल बी 3, जो कि हम लास्ट में लिखेंगे. ऑलराइट, now you can see students that there are two ligands. One is NH3, so uske liye we will be writing amine, and for water we use aqua. And how you are going to write it in alphabetical order. So AM is there and AQ is there, so amine will be written first. Okay, so firstly you will be writing triamine, and no space should be there, triamine. Then we will be writing triaqua, no space. Now you have to write the name of the metal. Now this is a positive complex ion, so the name of the metal will be written as it is, chromium. And now write the oxidation number in bracket 3, and at the end whatever counter ion is there, so it will be chloride. Okay, this is how we will be writing the name. Same goes for the next one. Like here you can see you are having this CH2, CH2, NH2. This is your ethylene diamine, and 3 ligands are there. So already it's a bidentate ligand, so you will be using the word tris. Now here you have sulfate, na, 2 minus. So since there are 3 sulfates which are bonding with 2 complex ions, so charge on each complex ion would be +3. Okay, +3 hoga. All right, and the oxidation number will also be +3 for cobalt. Main hota hai yahan par oxidation number find out karna. Ab because ethylene diamine is a neutral ligand, so oxidation number will be +3. Okay, we don't have to write the number of cations and anions ki 3 hai, 2 hai. All right, so it will be tris, ethane 1 to diamine, cobalt 3, and after that sulfate. Okay, now another one is here. So AgNH3 twice, AgCN twice. So first case mein, now here in both the cases the oxidation number of silver will be +1. Okay, तो अब यहाँ पर प्लस होगा और यहाँ पर माइनस होगा. सो अगेन अमीन इज न्यूट्रल लिगेंड, तो यहाँ पर आ जाएगा आपका +1. सो इट विल बी डाई अमीन सिल्वर 1 and dicyanide. So CN is there na, dicyanide. Now this is negative. Okay, keep that in mind. This is a negative complex ion. So इसलिए silver को हम as it is नहीं लिखेंगे. We have written argentate. Okay, argentate 1. So यहाँ पर भी जो silver का oxidation number होगा वो 1 रहेगा. All right. So this is how we can name these coordination compounds. Okay. So this was regarding the nomenclature, students. In the next lecture, we will be talking about the isomerism, and then we will be learning about the valence bond theory, about the bonding and all, how the bonding happens. So today we have learned about the introduction, the various terms that are used in coordination chemistry, and then the nomenclature. So please revise all these things, and in the next lecture we will be continuing with the next topics. If there are any doubts, please let me know in the comment section. Okay, so until then, take care. Bye bye. Thank you.